Do you ever just hachi me mom, or do you just hachi me?
Okay, so I have no idea what script I used for the intro, so let's just look for the limits. Well, now in order to produce with limits, it's always important that we take a look at their properties and how they work. For this, unfortunately, though, you would need to probably memorize this table and imagine these in terms of f and g, as I'm gonna put these limits differently. But I know you got this. Alright, now we're out with the boring stuff. Let's get into the best part of limits, the direct substitution. If you ever find a function to be continuous in which the limit is equal to the function defined at x is equal to c, you can straight up just plug in your x value into the limit. And if you were to do so with the function, let's say x squared minus 4x plus 2 all over x plus 1, all you would need to do is plug in that x value. Saying the limit approaches 0 and the function is continuous, just plug in the 0 into those x values and get an answer, which in this case would just be 2. However, if you were to get a limit that is indeterminate as 0 is over 0 or infinity is over infinity, there's two ways you can approach this. One way involves L'Hopital's method, but I won't go over that yet as that has to do with derivatives. For now though, assuming you only know limits, here you would just attempt to factor out the limit in order to fix the indeterminate solution. Let's look at the function x is over x squared minus x. If the limit were to approach 0, you would get a solution of 0 over 0 due to direct substitution. So your best solution here is to factor. Taking the x out of the top and bottom, you factor out and you would get 1 over x minus 1. Now with your direct substitution, just plug in that 0 and you would get an answer of -1. That's it. That's the limit.